Hello guys, welcome back again, and let's continue to the circular function. Okay, last time we talked about ASTC, and hopefully you guys just give yourself enough practice because it's really important. And after the 6C, I think I'm gonna give you guys some exercise, or let's talk about final year exam questions regarding to this and help you to solve it. Okay. So for 6C, it's symmetry properties and the Pythagorean identity. Basically, it means complementary angle formula. Okay, but they just gave us a name for complementary relationship. Some people feel like these two things are really difficult to remember. I cannot agree more, but I can give you some like not really like the proof, but the way to help you to understand it. Okay. For example, I take this one. First, I give you the triangle, of course, the right angle triangle, right? And this one is going to be your theta, and this one going to be your pi on 2 minus theta. Makes sense? So this is my A, my B, my C. So in this case, sine pi on 2 minus theta is B over C. Make sense? B over C, opposite over hypotenuse. But at the same time, my cos theta is adjacent over hypotenuse is B over C as well. So essentially, they are the same thing, right? I use this one to help you to get the idea of this guy. Okay. So, and for the later one from the diagram to the right, you can essentially apply the same thing, but just make sure our angle is back to the second quadrant. So our sign always be positive and my cos will be negative. Okay. That's the for it. And another one is because we defined in the unit circle. Okay, so our 0m squared plus my mp squared equals op squared, which means cos square theta plus sin square theta always gives me 1 square, so which is 1. Okay, this is called the Pythagorean identity, and it's important for us to do remember and to use it. I know it's not required and it's provided in the formula sheet, but you have to, I mean, familiar with this and recognize how to use it during the questions. Let's keep going. For example, over here, okay, my sin x is 3 over 5, and my x is at second quadrant, which is ASTC, right? So which means my cos x will be less than 0, and my tan x again will be less than 0. Okay, because why should I know this? Is because my use cos square plus sine square, sorry, cos square x plus sine square x gives me 1, and my cos x will be plus minus 4 over 5. Okay, and my x in the second quadrant, so my cos x will be purely negative. Okay, which means negative 4 on 5. And again, my tan x will be negative 3 on 4. Okay, that's, and for my 6c, it will be sine x cos alpha tangent theta to give you this, and you have to use complementary relationship to help you to get the values required. Okay, and for 2, it's just test us for the Pythagorean identity, which means cos square theta plus sine square theta equals 1. And for 6D is another important thing because they tell us to how to graph the sine function and cos function. This is should be familiar with you guys, and you guys learn it in year 11. So we're just saying for normally for sine x, our period is 2 pi, and this is periodical functions, and the maximum minimum value is should be between -1 to 1. So which means the range of my sine x is -1 to 1. And my domain, if without any restriction, is just R. And again, our amplitude, okay, amplitude just means the distance between the mean position and the maximum position is called amplitude. Or you can give another definition like distance between the mean position and the minimum position. Okay, same thing is called amplitude. Again, for cos x, period is the same, amplitude the same, range is the same, but you should realize when my sine is 0, my cos is 1 or -1. Okay, because they have the square adding together equal 1. They have this property. And this is pretty important. Noticing the graph of y equal cos x is the graph of y equal sine x translate half pi unit in the negative direction. This is testable, okay? And this is can link to our complementary relationship. In 2016 final year exam 2, I think question 1, if I remember correctly, there are 3 marks involved with transformations, and you need to figure out how to convert the sine to cos or cos to sine. Otherwise, you're going to be really frustrated in that question. And for that part of questions, I think only less than 20% or even around 10% people get that one correct. Okay. And of course, sine cos is pretty easy. And for our year 12 level, we need to use some graph transformations, which means dilate factor A and N. Okay. So what's N gonna cost us? The N gonna change our period. So for in this case, our period becomes 2 pi over N. It's the same. It's a new period. Okay. And our A gonna change our range, which is become negative A to A. If my A is positive, if my A is just negative, just become A to negative A. Okay. That's the essential things to remember. See over here. If the book just write A, maybe they just assume that A is just like a positive number. Okay, for me, I will write the absolute value of A. Okay. For each of the following functions with domain R, state the amplitude and period. This is essential for us because for every time for exam 2 question multiple choice 1 or question 1 or question 2 should be testing you about the domain range and periodical functions. Amplitude domain range is a really high chance to be in there, and you can just remember the formula and practice it and use it. So for question 11, they give the sequence of the transformations. Again, you can use our coordinate method, or you can just use the properties of circular functions to get. Either way, it's fine. Okay. For 12, they ask to sketch. Remember, one complete cycle just means the whole period. Okay. One complete cycle means the whole period. But for this period, normally we choose start from 0 to the period, but it really depends on the question. Sometimes they ask you to draw from full pi to pi or negative pi to 3 pi. It's really different. Okay, just read the question carefully. And over here, they ask you from 0 to 4 pi. For this guy, we got so many periods, right? Our period is just pi, so 4 times. And this is the 6D. I know it's really quick because we covered this one in our year 11. That's why I just want to refresh you guys' memory to get this sort of things. So let's do the short summary until here from 6A to 6D. So the first one is just tell us again with degree and radian, and I emphasized in my last video, the radian is pretty important and is used widely during the final year exam or during your SAC. So make sure your CAS is in the radian mode, except only for you really need to find the degree. Then later on, the second part is again give you guys definition for why we call sine theta, cos theta, tangent theta as circular functions, because we define them in the unit circle. With this unit circle help, we connect our coordinates and cos and sine, right? Then we get the ASTC stuff, which means quadrant 1, all circular functions are positives. Quadrant 2, only sine is positive. Quadrant 3, only tangent is positive. Quadrant 4, only cosine is positive. Okay? So with this help, we can expand our special angles. For example, before that, we only can know the special angle of sine pi on 6, which is half. But actually sine 5 pi on 6, again, it's half, right? And of course, my sine negative pi on 6 will become negative half. Okay, this is used by ASTC and our special angles. And for later 6C, they give us the complementary angles, like 90 degrees or I should say pi on 2, okay, such as sine pi on 2 minus theta will be give us cos theta. And later on, the trigonometry identity, or we call it Pythagorean identity, which means cos squared theta plus sine squared theta, just like 1. Okay, we're going to use this one to help us to find the theta value, or even like cos theta or tangent theta as requirement. And for this one, again, we just tell you guys about the basic graph of my y equals sine x and y equals cos x. And you have to notice the basic period 2 pi. If you have n in front of x, just 2 pi over n. And if we have a in front of our whole function, the range suddenly changes to -a to a. And the amplitude just defined as the half range, or you can just remember the mean value, okay, the middle average mean value to the maximum, or the middle value to the minimum. Okay, they all called amplitude. Okay, that would be all for today. For my next videos, we're gonna do some final year exam questions to help you guys familiar with a little bit with the sine cos. And that's it for today. And hopefully you guys learn more trigonometry through these videos. And please subscribe my channel and click the like button. I will see you guys for next videos. Bye bye guys.